Some very complicated curves can be represented with parametric equations, but I'm going to start with fairly simple curves, like a circle. You know, a circle with, let's say, radius 5. If I make t go from 0 to 360, every point on the circle is going to have a form. For instance, here's a point at like 70 degrees. That's a t equals 70. It's going to be 5 cosine 70, comma 5 sine 70. And over here, at 190 degrees, at t equals 190, I'll have this point, which is 5 cosine 190, comma 5 sine 190. And that's true for any point on the unit circle, or if I throw a 5 in there, any points on the circle with center 0, 0, and radius 5. So the parametric equation would be x equals 5 cosine t, y equals 5 sine t. And that will make this circle. But one thing to see about this circle is that the circle is going to start at this point here at t equals 0, and it's going to go counterclockwise. So this is the point for t equals 90. This is the point for t equals 180. This is the point for t equals 270. So this equation here is going to be a circle, and the starting point is going to be there, and it's going to go around counterclockwise. If I want instead to make the circle go same circle, it will look the same after it's drawn, but I want it to go in this direction. Well, t is still going from 0 to t equals 360. But this time, when t equals 90, for instance, I wanted to make this point over here. And when t equals 180, I wanted to make that point over there so that it goes clockwise instead. Well, the way we make that happen is this point here. The angle is going to be sort of negative t. So the coordinates of this point are going to be cosine, I'll stick the 5 there, 5 cosine negative t, 5 sine negative t. Then when t becomes 90, and here's what the equation will be. Cosine negative t, that's 5 cosine, and 5 sine negative t. So as t goes, when t is 0, I'm still going to be at this point here. But when t becomes like 30 degrees, for instance, it's going to plot the point 5 cosine negative 30, 5 sine negative 30. So it's going to plot the point, over here. And in doing so, we create the same circle, but it goes counterclockwise. So negative t makes it go negative t makes it go clockwise, positive t makes it go counterclockwise. Another thing I can do, still creating the same picture, what if I wanted my initial point to be up here instead? I want t0 to be there, and I'll also tell you I want it to go counterclockwise. Well, the way I make that happen, it's not very different from the first one. It's 5 cosine, 5 sine, but instead of t, I'm going to say t plus 90. That way, when I put t equals 0 in, it's going to do 5 cosine t 0 plus 90, which is 5 cosine 90, and 5 sine 90. So this point is still 5 cosine 90, 5 sine 90, but it happens when t equals 0. This is our starting point. And if I say negative t plus 90, well, that will still start me up at 90, but it will go clockwise. So that's how I can make circle centered at 0, 0 I could change this 5 to make a different radius. Whether that's negative t or positive t determines whether it's going, if it's t or negative t determines whether it's going counterclockwise or clockwise, and the plus 90 causes it to start at 90 degrees, so it starts at a different spot. I could also make a circle have a different center. Here's a center at 5, 3. And let's say I want to make the same circle And just to make it easy, I'll have it start at this point, at like the 0 degrees point, and I'll have it go counterclockwise. So the way I do that, it's almost the same as before, 5 cosine t, 5 sine t. But that would make it centered at 0, 0. By putting a plus 5 here and a plus 3 here, the points all end up on around this circle instead of around the circle centered at 0, 0. So we see this a lot with this sort of two parts. This is sort of the center itself, and this is on the circle. And if the circle's not at 0, 0, this happens. Likewise, if I want the circle to be going counterclockwise, I can throw a negative, or clockwise, so I can throw a negative t in there. If I wanted to start down here and still go counterclockwise, I'd have to throw in a plus 90 there, or there. Sorry, make that plus 270. So there's different things I can do, and I recommend you mess around with different circles like that. We could have something more complicated, like a circle that starts off centered at 0, 0. I'll go radius 3. And it slowly, as it's spinning, it moves to the right until after 360 degrees, it's here. The center's at 0, 10. And that would create some kind of curve. Let's say I'm tracking this point down here. And I have to tell you whether it's rotating clockwise or counterclockwise. This isn't like a rolling circle, it's more like sort of floating to the right, so I can sort of choose whether it's going clockwise or counterclockwise. And I want to see what happens with this point. It's going to make some kind of curve, maybe something like that. It depends on how far the circle goes, whether what that curve looks like. But I want to show you how to find the equation of that curve. Imagine the circle wasn't moving. Well, in that case, it would be x equals y equals, this one has radius 3. So it would be 3, this one's going clockwise, so it would be cosine negative t, 3 sine negative t, plus 270, that's what makes it start down here. Well, that would just go like this, right around this circle. But I want the circle to move to the right. Well, in order to make the center go to the right, keep in mind the y value of the center does not change. It's always 0, so I don't need to do much there. But to make the center go to the right, I have to say t over 360 is kind of like a percentage times, in this case, 10. That's it. What that will do is it will move the center of the circle. It will start off at x equals 0, and after 360 degrees, after one full revolution, it will go to 10. One last example for this video. Let's imagine I have my circle starting at 0, 0, but now I want it to go to 10, 4. Actually, let me make this just the last example for this video. Let me start the circle up here at 1, 2, and have it go up to 10, 5. The center, that is. So it's going to make some kind of weird thing like that. Okay, I'm going to build this thing up, x, y. This circle's got radius 5. So 5, 5, cosine, sine. I have to tell you which way it's rotating, just to make it. It will make the curve. This curve isn't necessarily accurately drawn. Let's have this one going. I'll trace this point, and I'll make it go counterclockwise. So maybe this thing has some kind of weird looking thing. I'm not sure what it looks like. It doesn't matter so much. What matters is how we can create the equation. So 5 cosine t plus 270, t plus 270. The 270 is there because it's at the bottom at the 270 degree mark for starting, and the plus is because I'm making it go counterclockwise. But now I need to add on what happens to the center. Well, the center starts off at 1, 2. So just throwing the 1 and 2 there, that would make it go around this circle. But in order for the center to move, I need to add on, it goes from 1 to 10, so I need to add on t over 360 times 9. That way, when I get to 360, this turns into 9, and 1 plus it becomes 10. And the y-coordinate is going from 2 to 5, so I have to go plus t over 360 times 3. So that covers certain types of circles and moving circles. They're kind of floating around. We have to tell you sort of what distance it's covering. In the next video, we'll see what happens when it's rolling and we don't get to control how much distance it covers in one revolution.